ShotBot, 3D printers. This is the Ultimaker 2 Plus. This is one that we have not upgraded, and it therefore is missing one part that the old ones actually have. The old ones have a tensioner on the back. This one does not have a tensioner, and I purposely selected that because if you really look up an Ultimaker 2, you will find that it doesn't have that tensioner on the back. This is what the front looks like. You have your print area. Down here, you've got the SD card slot where you can put in and out an SD card. This is what you're going to store all of your files on. I bought a bunch of extra SD cards for you guys. It used to be, back in their day, you couldn't use anything other than my computer or our tablet to be able to store anything on SD cards because your computers back in the lab don't have SD card slots. So, I bought you some. And they look like this. And these little things are USB drives that have SD card slots in them. So you pull off the little cap, and it's a USB 3, though I don't think any of our computers in the back have a USB 3 port, but when we upgrade, they probably will. And then right here, you would put in either the SD card, or you would put in a micro SD card here. Levi has had some experience with this recently in the past. And Levi, they go in sideways? Or do they go in this way?
They go in with these metal parts that look like rectangles. Yes.
So they go in like that?
Yes.
Okay. And then if you have a micro SD card, which we do, I bought some of those for you as well, then you would put it in the other side. Now this is a micro SD card adapter with the SD card inside of it. You guys have any experience with micro SD cards? Some of you probably do with your phones, right? Please don't steal my micro SD cards. They are. They're itty bitty tiny. And they are also, let's see if it'll focus on it. Probably not because I got other things in the background. They're 32 gig, tiny little micro SD cards. And they slide in the tiny little slot. However, if you have the adapter, no reason to worry about sliding them into the tiny slot or even really taking them out of the adapter. The only thing you would do that for is if you were planning to use one of the tablets. And right now I only have one tablet here. And in the back of the tablets is an SD card slot. However, you have these now. You can just plug them into the USB ports. And the tablets in their little holster, I don't know what I did with my tablet. And their little holster has, when it's plugged in like it is now, on the back sides here are SD card slots. Is there one on the other side? Is it a blue one? So those blue ones are USB 3 slots, and that will make this transfer of files even faster. Any questions about this? Okay. This keeps you from having to use my laptop, which is a good thing. I promise. And then we'll store them in these little yellow containers. Do you see over there on that side of the classroom the clear and white drawers? One of them has been left open. You see it up there on the countertop next to the window? See that? In there with those other little yellow boxes will be these, and this is where you'll go to get these out. When you've taken one out, just let us know you've taken one, put it in your machine back in the lab, and do what you need to with it. When you're all done with either part, put them away. Don't leave them back in the computer lab so that they go missing. Cool? All right. There's one other micro SD card. There's 6 of them in here and 6 of these readers. But there's one other micro SD card that I bought that is currently in which machine, Levi? Which one did you put it in? Do you remember? In Flash? Okay. Then there's other ones that look like this one. Some of them look just like this. Some of them don't. Some of them have different stickers on the front of them. But they're just regular SD cards of varying sizes. This was 4 gig. Any SD card will work in there, but I'd recommend you don't just go plugging in any SD card. Use the ones that we have. These 6 plus the 7, I think it's 7 that we have for the Ultimakers already. The 1 micro SD and the 6 that came with those 6 printers. When you put them in here, you just click them in. That's it. When you want to take them out, press it, pull it out. Cool? All right.
You put it in your rectangle bits first.
Yeah, just like you do the reader on pretty much any SD card slot. Okay. If you do wind up having to use my computer, the SD card slot is over here on the side, and you'll see that in Luca's video that they're making for you. Cool? That little bottom one down here, that's the SD card slot. This particular machine is named Superman. Why? Because we chose that this semester. The other ones have other DC character names. The one on the far left is Wonder Woman, followed by Martian Manhunter, then the Flash, then what's the next one? Green Lantern. And the next one? You got it, Aquaman, okay? We do have some Marvel ones, and maybe in the coming semesters we'll put those on, but right now we have DC ones on. These do come off, so if you ever notice that they're off, they're just taped on, and they're taped on these little buttons that are also wheels. See how I can spin it? And then I can also press it like it's a button. See how easy they come off? And they were made with, you know it, 3D printers. All right, let's take a look at the back side. So this is where you put the filament on. These little toggles right here, these little buttons that you can press. They're not super fancy. They just kind of look like little levers. And they simply release the 3D printed or 3D printer filament. Can you guys see that? Squeeze, just gently, and this pulls off. Okay? All the way, just like this. These new ones are real short, so it's just going to be wide enough for your 3D printed material to go on there. And it just slides right back on. Got it? Does that make sense? You'll change this filament a lot throughout the time that you're using it. And you'll notice that we have a little bit of silver left. I think this is all the silver we have. Is that right? This is all the silver we have left? It is your fault. This is what comes with these printers. It's all right. You used it well. This is what comes with these printers. So we're not going to get any more silver unless my director decides that silver is a color we should buy. We have a variety of colors to include a hot pink color. We have neon pink, neon yellow, a clear blue like you saw with the Superman. That its little emblem around on the outside is blue, but it's also clear so you can see through it. We have a black now that's PLA. We have a lime green color, a clear green. Yeah, it's dark green, but it's like a glass bottle green. A what? Orange. There's a white ABS. I'm working on getting us some white. We do have Riverside colors. So we have purple, black, and gold. And it's a gold-looking filament, much like this is a silver-looking filament. But that didn't come with white somehow as that accent color. But I think we can get our hands on some white PLA. We do have a little bit of clear left. Clear is a color that my director does buy for us. But there's a ton of them. They're over there in the drawers underneath the printers. There's 3 drawers that have been labeled with various different colors. So if you ever notice there's a color in the wrong drawer, please put it in the correct drawer. And the bottom right drawer is what we'll call the utility drawer, which is where you'll find this utility bag. Whenever we do have Clorox wipes, and this, which is Aquanet, which is our hairspray. It is actually really bad hairspray. You probably shouldn't ever really use it. But the Aquanet is the best stuff for us to use to adhere things to the print bed. And I'll show you that in a little bit.
And because the print bed is really hot glass and it's plastic on it, it can warp up a little bit, especially if you have like a long flat piece that you're trying to print. So you just use the hairspray and you spray it on the bed before you start a print job, and that kind of adheres the material to the bed.
Mm-hmm. And you'll find that there's a bunch of different techniques that you can use that we are not going to cover all of that during our session today, but we are going to cover quite a few things on just the basics of how to get started. You're all going to be printing the same things, which are your puzzle cube parts, and you're going to find that there are various different ways to print those, but what'll get really tricky for you is not only designing, but also printing your packages as well. That's going to be loud on the video. Yes?
The packages
In the past, I've let it be other materials. Per Davidson Desktop Doohickey this year, we have said, I'd like for you to 3D print them, or if we have the mill up and running, probably for next semester, then we can use that. I don't mind if you use other materials with the 3D printed material that you're using. They did that. It was screws. Pull it out. Yeah, it's in there. We never sold that one. Absolutely. The one that I kept, that I purchased and took home, is the one that I felt was, that's right. It was the one that I felt was the best one, but that doesn't necessarily mean that it was. And I can bring that one in to show you guys. You have to experiment with that. Probably some type of acrylic works just fine. It's plastic paint on plastic, basically, and it worked well. The technique is what was important. But that's something that you guys can talk to Ella Thompson about. All right. So, also with the back, you'll notice that there's a power cord. If you ever need to unplug the power cord from the machine, which does happen occasionally, most of them, and I think all of them now, have this little rectangular piece up here on the top, and you pull that back and then pull it out. And they're real stiff. Okay. Notice how this toggles back and forth. That's what locks it in. And there's only one way that this will fit inside of this hole. So pay real close attention to that. Flat part goes up, and to put it in, you just do the exact opposite of what you did to take it out. Okay? Usually helps to pull back on it and push it in. The other spot is a USB port. I think instead of a USB-A, they call it USB-B. You're familiar with it. It looks like this, little square USB, and it plugs into that USB port. The only reason you would do that is if I ever tell you to update the firmware. Most of the time I'm going to do that. I really want you to be skilled with what you're doing. It doesn't take too long to do, and that usually only happens when we update the software that runs the machines or figures out what's called the G code for the machines. And then this is the on-off switch. So if I ever tell you to turn off the printers, it's on the bottom back left-hand side of the printer. You just toggle it over, and it turns them on. And now you'll notice that it's kind of glowing with the LED lights. Go ahead. Let's get to that in a minute. Sound good? If I don't answer that question, ask me again, okay? Up underneath this is where your filament goes in. This is a motor that's behind here and a feeder. And this feeder, you can see that little silver part right there. This cabling is kind of in the way. It's a new feeder. I've never taken this one apart, but I have a good idea of what they look like on the inside from the last one that we had that I did take apart. They come as one whole piece, and I really don't want to have to take it apart. So we try really hard not to get things jammed in here or to get them cleaned out without having to take it apart. But you'll notice that if I lift up on this, see how I can pull that up a little bit? I'm moving inside a little spring-activated roller. And that roller in there, along with a knurled knob that you can't see that's attached to this axle, is what feeds this filament up. And I don't know if you can tell in here. See if we can get a clear shot of that. No, you really can't. You'll see it in a little bit, though. That filament has been knurled, which means it has little rough sides to it. That's how you can always tell if it's come back out of the machine. You can probably see it if you look close enough through this tube right here. And this tube can come out as well. And we'll show you how to do some of that stuff as you run into more problems and things need to be taken care of. It gets a little more advanced. I have literally taken apart all of these machines except for that feeder, to include on the very bottom of these machines, which is where you'll find the board. We've taken this panel off in the past to be able to replace pieces, components that go in there. And you'll also notice that down underneath here is a motor. And this motor is very much so just like the other motors that run everything for these printers. These printers are nothing more than a hot glue gun, that little copper extruder, okay, or nozzle on the end of the extruder, that lays down a fine material, just like a hot glue gun would melt down that plastic glue. This is melting down this PLA plastic to a tiny little thread and laying it down. We move it around. It's a CNC hot glue gun, basically. CNC meaning computer numerically controlled. You'll use a piece of software that creates what's called a G-code, and that G-code tells this printer how to move. How many times this servo needs to move or this motor needs to move to spin around, to move some belts, or to move some type of threaded rod. In this case, what this one is controlling is this threaded rod. And this threaded rod moves this bed up and down. This is what we would call the Z-axis. And you can see a tiny little hole. See that hole? And that little hole is for that little rod right there. See that rod that sticks out, that little screw? That threaded screw all the way up underneath there? See it there? And that little screw goes down into that hole and hits what's called the Z-limit switch. So if you ever get a code on this little screen down here that says something about the Z-limit switch, it probably means a piece of filament or dust or something has gotten down in that hole and it's stopping that threaded rod from activating that switch. See that little switch right there? That little rod comes down, hits that little switch, and tells the computer, tells the board that you've reached the limit for the bed. And it's going down. Now those same switches can be found up here. There's a limit switch. See it? And there's a limit switch. Sometimes you have to push those, sometimes you don't. Those limit switches are pushed by the extruder as it moves around. And it needs to know how to get back to home. So you can tell it through some of the advanced commands on this screen to return to home. You cycle through these by turning the knob. Okay? And if this is never, or if it's not on there, you can just rotate it like this. And if you go to maintenance, you can either redo the build plate, which means I'm releveling it, or you can go to advanced. If you ever have to level the build plate, we'll talk about it at that time. It's fairly simple. We don't have to do it all that often. Yeah. And I do it occasionally when I see that there's some issues to see if it solves whatever problem we have. Or the other option is to go to advanced. And under advanced, you have a lot of different things to choose from. To include heating up the nozzle, heating up the build plate, or sending the head, the print head, back to home. You can even hear it hit those switches. It'll hit them and come back and hit them again to make sure that that's where it needs to be. That's what they consider home. You notice that I was moving it by my hands earlier. What did I have to do to be able to do that? I had to turn it off. Because right now the motors are activated. They're saying, don't move, stay right here. I don't try to move it a whole lot without the motors, because you can wear the motors down, but occasionally you have to be able to move some things around. All right, up underneath here, you will find the print head. This is the nozzle. This machine is on and running. Don't ever touch this nozzle with anything other than these tools, because it'll burn you. We're talking 210 to 260 degrees Celsius. Quick touch, and you have a nasty blister on your finger. It is very, very hot. You're right, Luca. These are fans. There's 3 of them. 1, 2, and then on the back side, which you can't see at the moment, is another smaller fan that blows air across this. And what this is doing, fan 1, fan 2, and then a fan behind this. And what this is doing is dispersing the heat that's coming up off the nozzle to help keep it from melting through here, and it's blowing air across this, much like you would have on a computer, where you have a heat sink that sits on top of a chip. Well, this is a heat sink, and it pulls that hot air off of something, and then you blow a fan across it to cool it. Gives it a larger area to cool, or a larger area for the air to cool. And then, of course, you have your rods that your head moves around on, and then your belts that are back here on the sides. And they're all controlled by motors that are behind these housings on the left and right. Any questions about any of that? All right. Like it says on the board, this is the nuts and bolts of 3D printing. These are how the machines work. If you don't know how the machine works, it's like trying to use a calculator without knowing how to press the buttons. All right. But this is just one side of the 3D printer. I'm going to show you what it looks like when you heat up material and extrude it out. Then we're going to talk about how do you take your file and put it onto what you need to be able to print, which is a program called Cura. And like always, Lydia, anyone else, let me know if for some reason you can't see something, and I'll move the camera, and feel free to help me move this camera around as necessary when we're doing this stuff, okay? All right, so I'm going to heat up the nozzle. And notice right now that it says, what's that say, 22 degrees Celsius and 0 degrees Celsius. So there's something that's 22 degrees Celsius and something that's 0 degrees Celsius. One is the head, the other is the plate. You'll notice that this plate has the glass, metal, and then underneath that metal is another metal. It's this metal right here that heats up, and that heats up the glass. This metal is attached to these springs, which have little screws underneath it that we use to level the bed. This is just the frame to be able to move the bed up and down. All right, you might want to get closer so you can move this as necessary. Okay, I'm going to heat up the nozzle, and while doing so, I'm just going to rotate it all the way around. Sometimes it gets easier to take these off and rotate. This is why sometimes we leave them on this, sometimes we don't. It looks better when they're on the front, but often we'll put them on the sides as well. So I can roll this real slow like, and you can see how it goes up in temperature. I'm up to 140. I'm going to take this all the way up to 260. It's the highest setting for it. Okay?
It depends when it's normally printing. It goes up to about 210, I think.
Yeah, 210 I think is the typical setting.
In order to start a print job, but it can go up to about 260. It doesn't really matter.
It matters if you're doing a different material, but for PLA, 210 is what you need. You'll tell the printer what kind of material you're using.
You're probably not going to use anything other than...
Probably not. Not you guys anyway. You'll use PLA for everything. I have a few different other materials that we can use, but nothing that's going to be needing 260.
And you would spray the plate with Aquanet before you heat it up?
Before it starts printing, preferably before it starts heating. The print bed will heat up as well. Right now what you're seeing is the temperature that the print bed is at and the temperature the nozzle. The temperature, ooh, that would be bad. The temperature that the nozzle is currently at and the temperature that you've set it to be. Okay? And
how quickly does it heat up?
it's heated to 266 right now. So that fast. So fast that, break me off a piece that way. So fast that it's already starting to ooze out. Can you see it coming out? See that fine little thread coming out of there? She just gave you shade. She gave you sophomore shade. Watch this. It's so hot that it is melting this filament as I touch it. Yeah, don't touch it. And you'll find that filament will stick to the outside of that nozzle. That's why I use a little pokey thing. Okay? And you don't want to put your hand inside of here when things are printing. You might see me do that occasionally for things, but I'm pretty skilled with these things. I don't really want you doing it unless I've told you to do so, and chances are I'm not going to tell you to do that until you're probably out of this class, in case it does happen to you. I don't want anything to happen to you while you're in here under my watch. All right, you can also... Yeah, that's your other teacher's problem. Right. So, heating up the nozzle, sending it home, lowering and raising the build plate. Inserting material would be if I already have material unloaded and I want to put new material in. If I want to just move material, I can also do this. I'll click on that, and it'll go, oh, you want to heat it to 210. Well, you'll see this will start to drop now. And right now it's at 259, 258, 257, and it goes down and down and down until it gets to 210. So it maintains that. It regulates it at that temperature. Because that's all you really need for melting PLA at the right amount, the right speed. All right. Take care of that. So I'm going to now rotate this wheel around, which is going to turn the feeder on the back, which will push filament through, and you'll start to see it come out. And you can see it moving through the tube. There it goes.
Yeah. So it kind of comes out in loops and clumps at the start, so you just want to kind of grab that with the hook and just kind of pull it down.
Especially once it starts printing. All right, so you can move material to check for clogs or anything like that if you need to. You don't have to. You might need to, especially if material has been sitting here for a while. If the material has been sitting inside this printer for a while, what's happened is that that thick filament, like you see here, is going through this tube into this channel right here and down into this part, which is where the nozzle is. Well, once it gets down into here where the nozzle is, it's melted. And so when we remove it, it doesn't look fine and neat and trim like this. It's got a little, looks like a tear shape, isn't it?
Yeah.
And it's been pulled away from the filament that's still stuck in the nozzle. It's a little, we call it a PLA clump. There's a better name for it. And that will come out in front of material when you put on new material. You want to show me how to change material?
Sure.
Okay. Why don't you change it and I'll run this. Okay. The plump, the PLA, the plump of it. So you're going to have to go back to return. And then, yeah.
Okay, and then you're going to go to material and change. Okay, so it's going to heat the print head, and it's going to melt that material, and then it's going to push the material back out, which probably won't take that long to heat because
Yeah.
it's already pretty hot.
The head was already pretty warm. So as it's doing that, it's moved the print head to this center position here. And it's just waiting. In a moment, go ahead and turn it around. We're going to find that this starts to unravel, and you're going to control that, by the way, so that it spools it back up onto our spool, and it'll pop out here. And look at what it looks like at the end. You would cut that part off. So, I'm going to let go, all right? You see how it just kind of unravels right there. Now they're going to pull it off the back end.
And then you're just going to see where it would naturally go through those holes, and then stick it through one of the holes here. And then just cut off the excess.
I think I put it back. Other side.
And then just snip it off.
Excellent. Okay. And then this is now ready to be stored in another drawer. And now they're ready to put on the pink.
when you're reloading it, you want to go on this way, right?
Yep.
Okay, and then you just. So you want the material to be on the bottom, so don't put it on this way, and then so it's going to go up through there. And then just take the end and make sure that it's all, that it's not like looping over. Yeah.
Can I please add something?
Go ahead, Levi.
About 3 of the printers will have sort of a wheel over there where the machine is pointing, and you'll have to thread it around that.
Yeah.
Too.
Yeah, it's a little axle that sticks out, and you can run the filament around that. It's a tensioning rod is what that is. And it pulls the material away from the spool, pulling it out, keeping it under tension, and then you loop it up underneath that and bring it up into this little metal grommet.
And then you just feed it up, the material up into there.
Show them how you can lift this,
Mhm.
and it'll help push the material on up in there if you need to.
And see how,
There you go.
then you can see the material up in there. And then you're going,
Yeah, you don't need to be able to see it up through that tube because you just need it to get caught by the knurled feeder, that knurled knob.
okay. And then so you're going to, once you're ready, you remove the material. So it's going to start feeding the material up. And so the knurled feeder is going to move it. And then so once it's past this point right here, right about there, then you're going to press the insert new material.
Yeah, it's asking right now, insert new material from the back side of your machine above that arrow. That's where that little metal grommet is that she just fed it up through. And when you feel like it's come far enough, which is usually about this point right here, okay, which is, yeah, it's there now.
Mhm.
Okay,
And
so,
then you just press,
yep, you
and
tell
so
it
it's
you're ready.
going to forward it real quick.
It is literally going to fast forward the material through this tube. There it goes. It sounds like what?
Yeah, actually, that's a good point. Like,
It's okay.
you want a lot of this goes by sound, so you want to make sure that you're not hearing like weird like thumps
Clicking
and stuff
noises.
Like that.
Yeah.
Yeah, so that's the noise that you want to hear when you're fast forwarding the material, and if you hear something else, it means it's probably stuck.
So show them how that's silver and pink.
So you see, when it first came out, it was this silver, so there was still silver left in there, and then there's the pink.
Let me see. So it literally pops it like a zit out of that extruder. I think it's very satisfying. And then once you have the pink stuff coming out, it says, "Are you ready? Does this material come out?"
Mm-hmm.
And now it's asking.
What material that is, and so pretty much everything you're going to be using here is PLA. If for some reason you use something else, you just select ABS or whatever else. But
And you'll notice at the bottom it's telling you information about the PLA. So it's 2.85 millimeter thick or diameter PLA that needs a flow rate of 100%. It needs a bed setting of 60 degrees Celsius, so the temperature for the bed would be set at that if you're using this. And you're telling the machine right now, this is the type of material I'm using, so that when it goes to print, it knows to use these settings. So 210 temperature for the nozzle, 60 for the bed, and a flow rate of 100%, which means it's pushing it out at a speed of 100%.
okay, and then you just,
It does. You can control those settings, but it does do it on its own.
and then once it goes back to the screen, then you're done, and then you can change the material.
That's right. You can do this in the middle of a print job. Is it what? Yes. The only person that's done it at this point is me. I don't. Mostly because you won't be here to do it at the times that you need to do it. You know the parts that I have that are green with red tops? That's how I did that. I printed until it got to that stage, and you'll see kind of where that or when that happens. And then when it got there, I paused the printer, and I changed the filament, and I put in the red, and I let it feed until the green was gone, like we just did with the gray and the pink, or the silver and the pink. And then once that happened, I started it back up, and then it started laying that top layer down. But I paused it at just the right moment to do that. You're not going to be around to do that. You're going to start a print job at 8 in the morning before school starts. Hope that by the time first period rolls around, whatever you've printed has stopped and is done. Or you have lots of things printing, or you have a day-long print job, something that takes 9 hours, and by the time school is over, you hope that it's finished because you've gone on to class and lunch, and you've come back at lunch to check on it, and you'll find that all 6 of these machines will be running constant, probably starting next week.
It was a lot harder last year because we only had 2 printers and neither of them wanted to work at the same time. So it would be, you just kind of have to get here at like 6 in the morning if you actually wanted to print.
And stay till 6 at night,
Mhm.
which Luca and her teammates did. A lot. So, we'll go to return. Now, at this point, I'm going to switch how we're seeing things, and let's do this. You want to tell them a little bit about Kira?
Okay, so this is Kira. Kira is a program that basically takes what you have saved as an SPL in Inventor and it turns it into G-code. So G-code is what these things read. You don't really need to know a lot about it for using the 3D printers, but it's pretty interesting. It just basically, it's a lot of instructions that tell it where to move, how to move, what points to go to, and so all of the machines that we have here pretty much run on G-code. The ShopBot does, the CNC mill that we have in there does, and these do. So you can write your own G-code by hand, but Kira writes it for you.
Which is a lot easier.
A lot easier. Trust me, writing G-code isn't fun.
And there are some things that you can print. There's entire websites dedicated to being able to download things. Please don't. We want you to make your own things and then print. But you can download some files that there's this stuff called Loopy Flowers, where this guy has gone in and he edits the G-code so that it purposely prints without touching the bed, and it drops material as it's cooling. It makes little loops, and they're really pretty flowers. And as we get more and more advanced with using these, we might teach you how to do some of that stuff. Maybe by the time you're seniors, I'll have figured that out. Luke will have figured it out. And maybe we can teach you. Do me a favor. Click this button.
Which button?
Who hates using the mouse?
Millennial.
Yeah, millennials who hate using mice who love little trackpad ones. I don't hate them. Okay, so turn the camera so that it looks at me. And then I want you to use the mouse to be able to point and stuff. Okay? That's not looking at me at all. Not even close. Like, I want to see this. All this right now. I want to see me and all of this.
Is that good?
That's not bad. All right. So when I point at things, point at it with the mouse. They'll see the mouse, and then they'll also be able to see me. Hey, look. He's using a mouse. Basic settings. All right here. These are all the basic settings. And some of them that you'll wind up getting into will be more advanced settings, which we can access through this button right here. And you'll find that all of these things have little drop-down arrows. Grab my screen and just drag it off to the side so you can see all this. There you go. So you'll find all of these little drop-down arrows are things that you can adjust about your print job. Not necessarily the printer always, but about the print job. Right now we have it set to a profile of fast print. Change that fast print for us. Put it on high quality for the extremeness of it. And go ahead and say, let's see, it says selecting high quality replaces your current settings. You want to save your settings in a custom profile. Don't tell it to create a profile if you want to change your settings. So see what it says if we do discard changes. Okay. Now look at the quality for the layer height. As it goes around and makes each pass, it's going to lay down a layer of material. Each pass is a layer. And that thickness is important for quality. It also drastically increases
the amount of time that it will take. Because if you have a layer, if you have a piece that's like 1.5 inches tall, and you have it at 0.05 millimeters, it's going to take a lot of layers for it to go around and get to the right height, right? So
a whole lot of layers, thousands of layers.
And then so you can change the amount of layers that you need by changing the layer height. So if you have bigger layers, that requires fewer passes, which requires shorter amount of time.
So high quality, you're probably not going to want to print. Take them to the middle quality. So normal quality, it puts you at 0.1, and take them to something that's fast, and it puts it at 0.15. Now, a lot of these things are very dependent on each other, like layer height, and then shell thickness, bottom layer, top layer thicknesses. It's all varying on the layer heights. And you want to make sure that these things all kind of work together with each other. Go back to simple. Most of the time you're going to be printing on this. It's easy, it's quick. As you get more advanced, use the more advanced settings. But right now, simple with a light infill. An infill is, see if the blue airfoil is in that little bucket up there. To your left, right in front of you. Is that blue one in there? This is infill. You see how that's got this kind of web shaping to it? I'll let you pass this around. So that infill is what gives it structure. It's also what's going to give it a lot of its strength. You don't need a whole lot. Light is very minimal infill. Take us back to that advanced setting. You'll find that this has infill density of 18% on light. Now you can change this. You used to print at 20, 15, 10, and you start to run into big spacing. Yeah, a little bit of drooping.
I want to. Yeah, so this is like 70, did you say?
I think it's 70.
This is really high infill compared to what you're going to use. And so this is pretty strong, but it's pretty strong even if you use like 15% infill.
Yeah, they really wanted you to print that at 90 to 100% infill. I printed it at 70, and it was mostly solid. It means that 70% of the inside of it, 70% of the volume is material, 30% being air. Whereas most of the time what you guys are going to print, like this guy, and I'm going to pass this around too. This is the base. This took 9 hours to print. No. Hold it up to the light when you look at the inside, and you'll be able to see through and see kind of what the infill looks like on it. This is a 10% infill, I believe. And you'll find that there's gaps in the corners. There's little holes where material didn't lay down and touch. And that's because that gapping, that infill distance, allowed for material to fall down inside of it and didn't reach where it needed to be. Whereas I think this is 20% infill, and you can look at that and see it doesn't have gapping. 15 to 20% usually doesn't gap.
What would be the sort of time difference between, say, a light fill for like a puzzle cube piece or a?
This is a good question. This kind of leads into what I want to do next. Load us a part. So over here on the left, we can open a part file. And this would be where we create an STL file using Inventor. And then we would use that STL file to be able to put into here. Go ahead. Cura? Cura's free. How many printers did you put it on? Or computers did you put it on? One?
I've only put it on one.
Which one was it? The first one when you walk in on the right?
It was the first one on the side.
On the left?
Yeah.
When you walk in. First one on the left has it. We can download it though on all the machines. Okay. It's really not that difficult to do. It doesn't take very long. You'll need some of my credentials to be able to put it on there, but I'll be happy to type those in when you're ready. Okay. Go to ID. And then take us to Juco's Puzzle Cube. Actually, go back. Whose did I do? I did yours, didn't I? I did Kaya's Puzzle Cube. Take us to Kaya's. Okay. I didn't do any STL files yet, did I? Snap.
Trying to go over saving.
Yeah, let's go to Inventor. I have it down here. It's already open.
Okay.
And then let's open up hers. I'm gonna
You'll
show
find
you.
out.
Save it as,
Go to Kaya's right here.
or you can type dot STL.
Click on it.
I will.
Computer's going slow. Not responding.
Okay, and then
Let's go with
gold part. That's cute.
all right, let's do the gold. It's gonna come out pink. I was gonna suggest the pink part because then you would have one printed that was pink.
Oh. Do you want me to do that?
No, we'll make the gold part pink. Why not?
Make the pink part gold then.
So whenever you open Inventor for this, as you guys know, it takes it a minute to load in the file, but it's loading it. Just literally take it a second. Yeah. All right. Ooh. complicated part too. So at this point, we don't care what color it is because we're going to print it a particular color. You're going to go up here to the file button and go down to Save As and click the flyout window. Don't click Save As. Click the flyout window and go to Save Copy As.
Okay, and then you're going to go right down there to this Save As Type, and then you're going to go to .stl files, and then
And you'll notice nothing is here because
you haven't saved anything in
We've
this
never saved
folder
anything
as
in
an
this
STL file.
so Kai has never saved it that way. I've never saved it that way. Luke is going to save it as an STL, and notice that it keeps that same name, gold part.
And STL stands for like stereolithography file
I believe
format,
so.
but some
You can
trivia.
also type .stl.
You can.
You
Absolutely
sure could do
you can.
that if you were And so like, inclined. is that a shortcut-ish? Kind of, but it doesn't really save that much time. Doesn't really.
And it should have saved it where we put that original file. And there it is. And notice that it's kind of, don't ever tell Ultimaker people this, but I also have a MakerBot, and for whatever reason my computer likes any STL file to give it the icon of a MakerBot, or of a Maker file, and that's what that icon is. But that's the STL file. Go ahead and double click on it, and it will load it in. There's our part.
Yeah.
Now I've set up my computer so that it knows when I make an STL file to convert it from being inches into millimeters. Because as you've seen with all this stuff, it wants millimeters. You likely won't do that, and we'll have to scale things. I can show you how to do that later, but I kind of like to let you stumble into that problem.
It's cute.
Your video addresses it, I believe, right?
I think so. I also if you want, I have a tiny puzzle cube, which is like the cutest thing. That it's like half the size of a normal puzzle cube. So that was a fun thing. Like you can if you just click on the part,
Drag
then you
this up
can.
here so that it's
Rotate it.
That's what we're trying to go over.
let go. You've taken me away. How'd you do
Where
that?
did it go?
I don't know how you did that. Click on this. All right, go back to Kira. I assume I'm still there. Hopefully I'm still there and you can see me.
Okay, and then so there are all these different options here: scale, rotate, and mirror, and per object settings. So if you go to scale, then you can change the size, which is what you'll need to do if you ever save it. If you don't change the file setting to millimeters in
You don't
Inventor.
convert the sizes.
So then
Notice
you
right
just-
now it's doing it at 100%, and these are the X, Y, and Z directions. So you got your X, your Y, and your Z directions.
And also it has uniform scaling clicked here, which is something you want to make sure if you're ever resizing something to make sure that you have uniform scaling. Because if you don't, then it's going to change one size without changing the others.
Right, it'll only change one direction size.
So
without changing.
then
it'll-
you'll have like a
it'll
really
not
ridiculously
scale it
tiny
proportionally.
puzzle cube.
Yeah, you want it to
That's
scale
just
proportionally.
really skinny this way. Okay, and then so you can scale to max, reset.
Don't scale to max, you'll print like 3 days long.
Okay, and then you can rotate it. So you'll see how you have these 3 circles, and so these are the different axes of rotation. So it gives you exact measurements so that you can see how much you're rotating it by,
So that was 90 degrees.
because it was. And then so you're gonna just slide that on the side.
Now it's important that we laid it down on one of 2 sides. This side, what's the other one?
You could also have laid it down on where's the where's the other side? Is there another side that you can lay it down on?
Pull it back up flat, go down just a little. Grab this green one again, tilt it that way.
Yeah. So you could also have printed it like that.
Now grab this blue one and spin it around, let's see if that would work. Oh,
it wouldn't.
and that doesn't work. This is a very complex part. There's only one side we could print this on. We can't print it on this side, but we have to build support material up underneath right here, show them with the mouse, up underneath right here, so that this overhang has the ability to be supported. Otherwise, you're printing material out into open space, and it's just going to droop. You don't want it to do that. I don't recommend you do this. I don't recommend you print it this way and do it with support material.
Because if you choose to do it with support material, that's going to add to the time of your print, and it's also going to use more material than if you just normally print it.
And you got to break that support material off, and where you do, it's going to
It's
be
going to have
rough.
a jagged edge.
Yeah.
Actually, let me back out. Well, you can't really see it that well anymore. But so one of these sides was printed with with support material
No
on.
way to do it.
And so you can see if you want to like pass this around, one side is really rough right here where the support material was torn off, and then the other side is like
Yeah, go ahead. Pass
very
that so they
smooth.
can see the fly. All right, so go ahead and lay it back down.
Okay, let me just reset it because I think I messed something up.
Excellent.
And then there you go.
Yep.
So
Show them the different layers that you can.
you can change it from this is solid. You can either do X-ray or layers if you want to do layers,
You just see through it. Shows you basically a wireframe on it.
which is kind of boring for these because they don't have anything inside them. But it was really cool for the when we tried to do the thousands block.
Yeah.
That was pretty cool.
Yeah, it was pretty cool. So click and drag so that they can see the top of it. Right, Mouse.
Fancy. Okay, so there you can see.
Now you see all this space around this?
Oh,
That's
is that the stuff that we see around it that they lay out before?
that's a skirt. This is a brim. And right now, that's because the platform adhesion that we have is brim. And we don't want that for this particular part. It's extra material that would help hold the corners down if we needed it. You have a long, thin piece, you'd want that.
Yeah,
But
really.
we don't. So we'll switch it over to skirt. You can deal with raft and brim later if you ever need to. Skirt is just going to lay a line around it to show where it is. And this is what you're familiar with, right?
And then with layers, you can also change the number of layers that you have.
So you can move through the layers.
Yeah. I can't print it. So you can see that it like lays down kind of a diamond lattice on different layers. So it'll just lay down like that a bunch of times, which will give it a pretty strong.
Take them all the way down to the bottom. You'll notice that it had 250 some layers that it was going to go through. So using a layer height of 0.15 and two, I guess it was probably 1.5 inches tall or 2.25 inches tall, whatever it was going to take 253 layers at 0.15 layer thickness to do that. However, the bottom thickness is 0.75 millimeters. So how many times will 0.15 go into 0.75? And we can actually look at that here. The first layer is going to lay the skirt, and then it's going to do a profile, a little shell all the way around it. And then it will lay one solid layer. It'll go back and forth and back and forth and back and forth, filling this all in. And it'll do that for a few layers. Gently drag it up. You see layer 2, layer, it's really hard to do. Oh,
There's
go
like
back to
up
5.
layer 4. No, layer 5 doesn't have it.
Layer 5 does have it. And so you can see that on layer 5, it's got this thickness to it. So what's 0.15 times 5? Right? 0.75. Oops, that's a 7 on 2. So 5 times 1 plus 2, 75, 0.75.
Mr.
So it's
Davidson
going to
can do
take
math.
5 layers to go from one layer height of 0.15 to a bottom thickness, the bottom of that part. This part right here. Notice how it's all shiny. That was what was laid on the bed, whereas this part is not shiny. That was what finished on the top layer. And that layer, as well as that bottom layer, was 0.75. Yeah, take that. Okay. And then as it goes up, it does the infill, and then when it gets to a top layer, it lays that top layer down and continues the infill for the rest of it.
And then you see it does another of the solid layers right at the top.
Yep. All right, go ahead and take them back to solid and turn them solid. Notice down here, it's telling you how much time this is going to take to print.
Is that pretty much?
It's pretty close. It'll go a little bit longer because we'll probably tell you to turn the print job down with some parts. You will find that because it's a cantilevered bed and it sticks out, that if your print job's set at 100% in speed, it's going to be moving so fast that it does get into this oscillation where it vibrates, and that can cause an error in your print job. And if we notice that that's happening, we'll probably turn it down. I've found varying speeds work. We usually go to about 75%.
You won't always have to do that, but
A little bit longer. And that's where the time starts to get thrown off a little bit. But an hour, 38 minutes, not bad. I mean, you start at 8 o'clock, that part would be done within the class period.
Mm-hmm.
Go ahead, Kyle.
Is like the top of like not like the top, but like the top of the most of it, would that be the thick parts too? Not
Here?
that one, but
Here?
yeah.
Yes, that would have a 0.75. Anything that's a top or bottom layer where it lays that material down solid. Go ahead.
What would be the typical profile quality for our puzzle cubes?
Because we're using this newer version of Cura, I found that fast actually is going to work. And you can play with this, but a fast setting with the 18% infill is probably pretty good. I mean, 20% and it's going to be very solid. So 18% is pretty good. Change this to a normal quality setting. Watch what happens to the time and look at what happens to the other features this cartoon. So now I have a 20% infill. I went up by 2% on the infill, and now it's a 3, almost 4-hour print job. That's a lot. That's a lot of time. I decreased this by 0.05 of a millimeter.
And then
So
do you
my
want to
layer
show
heights
them how many different layers?
are much thinner. Yeah, show them how many different layers are on it.
So before you had 253 layers, now you have 379.
It's a lot more layers.
Take them to the fast while you're still on this. Or not fast, high.
Loading. So that would take 6 hours and 6 minutes.
Not too bad.
Yeah, for one part.
So 631 layers, and you went up another 2% with infill. So
Show them what happens if we put this up to a, well, go back to simple. Go back to simple. And do fast quality solid. Let's say you're like, oh, I want this thing to be solid and have no air in it. You want it to sink. Look what happens. And take off brim too.
7 hours and 32 minutes.
Put it on high. That's the closest.
It's
Put it on high.
Zoom in and out.
Bye.
Yeah, apparently it disappeared.
I think it's still there. I
computer
think
is just
it.
like,
Yeah, let's do it.
I don't want to do that.
But let's see if we
It might still be thinking, actually.
Yeah, it's not quite sure how to deal with that.
Yes.
Have you ever printed anything solid?
Yes.
Was it a mistake?
No. The little emblems that we have on the printers,
Are those also?
those are 3mm solid pieces.
Yeah, but they're this big, so.
It varied. It's multiple different print jobs, and they're tapped in together. So some of them take less time, some of them take more time. Make sense?
They're small and didn't take
Correct. We're looking at. I think I can put together some of the more simple ones. Superman was actually one of the easiest ones to put together, and that probably took me a total of 2, maybe 3 hours. I could probably do it in about. I could put them together in about 20 minutes, and it took the big blue part probably took 40 minutes or so to print solid. Again, only 3mm thick, and the big, pentagon shape on the inside. That's all the way through the blue, so there's nothing there blue printing out. Whereas, like say Wonder Woman, that's a big yellow ring with the tiara going across the middle. That didn't take very long at all. But the blue part and the orange parts took a little bit of time because they're solid and they take up a good bit of space.
Wasn't the fast print with wasn't it like an hour 38 earlier? And
Mhm.
that's an hour 24? Or is that?
I
Because you
don't
didn't
remember how long it was.
generate the brim.
Yeah, that might be the case. Adding the brim adds time.
Can you use hot glue gun on PLA? It's already been printed.
You mean glue? Hot glue?
Yeah.
No. Totally different size
I mean,
material.
can you glue two things together?
Yeah. I mean, I wouldn't. You can glue PLA stuff together. You usually would use like an instant bond glue,
Is that how you connected how did you do like the Superman?
That's all pressure.
Just
That's all
snap them
tolerances of
together.
about 1/1000th of an inch. So I can pop them out if I want to. He will separate. And so the yellow goes all the way through, and then the red just fit on top of that as well. I don't think I could probably separate the red from the yellow at this point because it's so tight.
I mean, if you tried really hard.
Yeah, you'd have to damage it really to get them apart. But that's the way that I put them in. So when I printed them, that's a more advanced technique using Inventor than the printer itself.
So would you have to, if you were like gonna do something like that and increase that and just have like a little part that's like 1/1000th of an inch greater, would you have to like decrease or increase the quality of it to sort of get that little bit of.
To get the detail?
Yeah.
Is that what you're asking? Maybe. I mean, I didn't use a thousandth of an inch. We're dealing with thousandths of a millimeter at this point, really, is what I dealt with. I designed them with millimeters in mind. And they print just fine with the detail. Now, if I wanted more detail, for example, I have a Spider-Man one, and the legs of the Spider-Man one needed to fit inside of little tiny openings. The openings were made just fine, but the legs themselves, to lay that fine of a material down, the printer was like, no, I'm not going to do it. And it stopped short. So there's little gaps at the end of the little red legs in the blue openings. And it didn't print fine enough. So the printer quality could have been changed. Now, there are things that we can do physically to the printer. I have other nozzles. I have like a 2 millimeter nozzle. Right now, there's a 4 millimeter nozzle. I don't want to change them, so we're not going to. It's kind of a pain in the butt for us to constantly change them back and forth. But if I ever needed to for some special project, I might could. And that can then be changed as well in the software so that it knows you're using a 2 millimeter nozzle. And then it'll take longer because you're only printing out 2 millimeter wide. But the layer height will also be a factor as well. And you don't want the layer height to ever be above 0.25 millimeters with a 4 millimeter nozzle.
Do you wanna like scale it down real small and print it or something?
Yeah, let's put it at about a half scale.
Why is it at 6?
Why is it
this?
not uniform?
I don't know.
What did I do?
I don't know. I don't know what you did.
Probably when you move Mr. Davidson off the screen.
Yeah. Maybe. Hit it.
Right.
Okay, so scaling it down takes 22 minutes.
Do
Let's go even less than that. Let's do a point, or let's do a 50 there. 50% there.
Are you actually gonna print this piece?
Yeah.
10 minutes.
Hey, you know what? Hit this reset button. Huh. Okay. Yeah. Go back down. Please.
That's weird. So this is the
This
third
is
one.
a third scale. Right,
Tiny baby.
This is taking it way down. Yeah, 10 minutes. That's good. Okay. So you saw how in Inventor we loaded a part and then we changed it to an STL. You know how to use Inventor. Now what you need to be able to do is take those parts and put them into STLs. There's other things that you need to learn how to do in Inventor. When it comes to keeping manufacturing in mind, you're going to want to make some crazy stuff. I get it. But you got to really keep manufacturing in mind. When Levi made his helmet, he couldn't just print the entire helmet. First of all, it was too big for the printer. And then it was going to be, that would have been like a 5-day print job. We're not running these overnight. You can run them as long as somebody's here to keep an eye on them, which varies from day to day. Hang on. So what he had to do was break it into 8 parts, 14 parts, and then glue them all together. You use hot glue with some of them,
Yeah, but I have to scrape it all off because it's way too thick.
and then you use super glue.
Yeah.
Yeah, use like an instant bond glue to it. So you can make some pretty complex things, and you can keep in mind how I have to manufacture this and assemble things in the end. Like for this guy, this was all one big print job, and I would recommend it 9 hours. I'm usually here for 9 hours, so I printed this here. Same thing with the lid, it was 9 hours. But I printed it upside down and had to do support material right here for all these numbers.
Oh, is that why?
That's why it looks like that, because it's support material that I pulled out. Whereas this I printed this way. But I had to get real complicated with this because this is such a tight tolerance that if I didn't put this hole in there, when I slid this down, it wouldn't open and close. So you can tell when I do that, it's pushing air out of this exhaust hole. That's why that's there. Whereas this doesn't have that. And if you hate nails on chalkboard, you're going to hate this. Air does not come out, and it's real tight. It's the same tolerance, but you can tell the difference. You also notice that I had to keep in mind how to get these things to lock together. That's why there's little finger holes here. Those finger holes match here as they do there.
Not to interrupt you, but if we want to get this done with it.
Oh, I thought you were getting it set up.
Okay.
Sorry.
Yeah,
Plug in
so-
the SD card.
Gonna take the SD card that was in this, and then plug it in. Yeah. Or just have like me. If I'm here, I can help you.
we stay here?
I mean, I stayed here till 6 like a couple times last year.
Yeah, and most of the time I was here with you guys.
Yeah.
Okay, so
So we're gonna.
they put in the SD card,
So
save
this
to removable
will
drive.
It's
If
not
you're
gonna-
on the tablets, and maybe on these, but not on my laptop, you can hit eject. But it won't do it.
because
for
it's
mine.
still in use. So you can just go down here and don't just take it out because
Hey,
you'll
pay
get in
attention.
trouble. Okay, so
Luke is telling you something important here.
this is how you eject it. Just go to that little up button on the bottom and then press this icon and then click eject the SD disk and then it will say safe to remove hardware. You can just press on it and take it out. Don't
Go ahead.
remove it without doing that because people will yell at you. Yeah, and you can corrupt the files and it's a mess. Okay, so then once you have the SD card in there, you just go to print and click on it and it'll read card and you just have to go right to go down to the bottom because it's the most recent thing that's been saved on there. Just
Yep.
and then so just check to make sure that it's the right part. This is gold part 4, so that's right, and then click on it. It's gonna heat up and prepare to print it.
So it's heating the print head and it's heating the bed. And when it prints this part out, it's going to start extruding out of the nozzle. The bed will raise up and it'll just start laying stuff down. That's where you want to take, and make sure it's sprayed because it's not. It always does way too much spray.
Not too safe.
I do this.
You're doing more.
I know. I do this. I go from that distance away. That's all you really need. Yeah. Spray from a distance so it coats. It'll be fine. You'll want this? That plate is also heating up, and as it heats up, that spray, that hairspray, starts to evaporate. And you just want a little tackiness on there. Gives it a rougher face to adhere to. It still comes out smooth. It just gives it a little bit of something to grab. Ultimaker actually suggests that you use a glue stick and then wipe the glue stick away.
But
Hairspray works great.
It's great for the ozone.
Yeah, we used glue stick at first. Also, with the old machines, before we made them 2 pluses and bought 2 pluses, we had just 2s. And you remember having to pull out the filament. We used to have to lay the filament out on the ground and cut exactly how much we needed, and then feed it in, plus an additional 3 feet to be able to get through the tube.
Wow.
Yeah, and that was because we were having a lot of issues with it getting bound on the back, but we've solved that problem, and that was just human error. That was just stop being a jerk and not catching it before it unspools. And that pretty much solved that problem. We have less and less print errors because of that now.
so a lot
Be
of
nice to
pressure.
each other so that you don't have to measure out how much filament you need.
Does it matter what type of hairspray?
Just, I mean, don't bring in your own hairspray.
Yeah.
Just use this. There's
You
like
want,
a
you
couple
want to use
bottles of
aqua,
it.
specifically aqua.
And it's
Looking it up.
And it's really weird to just bring in your own hairspray to school for a 3D printer.
Yeah.
Also, probably get like flagged by like a officer.
I use extra super hold. It's nice and sticky, and that's why. We use the I forget what they call this. It's not pump, but aerosol. I don't think it's actually using aerosol anymore because CFCs are bad. It says it doesn't use that. So
You can
it's
hear
crazy.
the fans on here just came on.
Yeah, so that means it's getting ready to do its thing.
Which hopefully it'll do before.
Nope.
No. So it's gonna go a little bit over, but not that much, I hope.
How much? 2 minutes. Yeah, give or take. And if you've already heated things up prior, it takes less time.
Yeah.
So if you know you're going to be using the printer, you can go back there and say, heat up the print head, send it up to 210. It takes less time to get the bed up to temperature, so it'll go quicker.
Printing it right after you change the material is the best.
Yeah, that helps too. Because it had to heat the material to be able to separate it.
There, and then you see the bed is raising, and then it's gonna come out in a sec. And you see, so it comes out all clumped, and then you just want to take that. And
If it does that, yeah.
peel
Yeah, you just pull it
away.
down. You should see it spool up like this.
Yep, and then it's gonna go over there, and you can just take this off. is really, really tiny. If any of y'all want to see my tiny puzzle cube that I have,
I don't know. We didn't check. I don't know how many layers it's going to do. It'll go relatively quick, though.
So the
I
reason
mean,
you
there's
have
like
Bob
there's
Ross
like
Rich
a
particular creative.
aquariums they have like cameras, like live cameras. I guess.
there's also like those like live streams of just like video cameras like at intersections of town. People like get really riled up about that.
It's like the what's the bridge?
Wow.
Yeah, there are a lot of fun live streams of just.
Anybody want to see these?
where people like get really hyped up in their cars.
Why?
Specifically red cars.
All right, so as we move forward, the other things you might want to do or think about doing today during lunch or after school is finalizing any decisions that your team needs to make about whose cube, colors. Start thinking now, if you haven't already, you should have been, packages, what they're going to look like, what kind of materials or colors you're going to use for that. And then drawing sheets. There's videos that I have on my website that talk about how to use these. Now, it was using 2014. It should be pretty similar. We'll cover some more drawing sheet stuff when we talk more about the drawing sheets that you need for your bracket assignment. The requirements, as you'll see back there, are to have, and this is something you might want to write down if you don't already have this information, are to have titles for each section inside of a border on a drawing sheet. Again, titles for each section inside of a border on a drawing sheet. The drawing sheet needs to be B-size. Say again. The requirements for your drawing sheet. Okay? Which is that thing that John's taking a picture of, which is a good idea. You'll notice that also up there, not only do I have titles, I have multi-view and isometrics, and that's covering the parts as well as the assembled cube. So you got to have all 5 parts with an isometric that has been shaded, which means the color has been turned on for it, and the multi-views, top, front, right side multi-views with proper baseline dimensions, no more or no less than what is needed. Top, front, right, multi-views with isometrics that have been shaded, which means colors turned on, as well as dimensions that are baseline dimensions. The multi-view of your assembled cube needs to have all 6 sides of it laid out properly. I chose that shape, that T shape, so that it was the bottom on the, it's a projection of the back view, or the back, is a projection of the bottom view. And I chose that orientation or configuration for it because it fit the best on my page. I split up all of my different areas with lines that are sketched. I labeled everything that I could to include item numbers that match my parts list. So all of my parts have little item numbers that match over in the parts list, which ones they are. And then that parts list also corresponds to the balloons that are on my explosions. I have an explosion for how my parts fit into my package, as well as how the parts all fit together. Even the assembled isometric views that I have are all labeled. Those assembled views are scaled down so that they all fit. I have 2 parts lists. I have a parts list for the package and for the cubes themselves, but notice how they're separated from each other. One is near the package, one is near the parts. And then those QR codes I've made, and there is no video for how to make those. We will try to make you one in the near future, but it is something that is relatively simple to do. Those QR codes link to the IPN file videos that you should make, and those videos are then uploaded to YouTube. So that's where those QR codes take you, and they show you how to assemble the thing, how to assemble the cube, and how to put the pieces back into the package and attach the package. And then, of course, there's your title block that needs to be filled out. The videos walk you through how to do some of that stuff. Some of it is trial and error on your part. Some of it's through iProperties. Some of it is text that you put into place in the title block itself. Yeah, it might. It might. Release that date stuff. 1 minute on the bell? Oh, 1 minute on the print. It says 1 minute. This part's going to go real quick. So good, yes. I sold the one that did it to Beth last year. Yeah, Elizabeth and Ayla and all that. So feel the top. Feel it's been smooth. That's why they did that. It helped smooth out where that inlay star was put in place.
Isn't the red that also feels like not very
Mine on the top, yeah, I was playing around with it on some parts where I've smoothed that out. Some parts that are not, like this is not versus this.
well, like,
Yeah.
it wasn't necessarily glossy.
Yeah. It's actually kind of gold. And we tried various different things, putting some oil on there to help sheen it up. So you can't. The best one that we got last year, the one that got the highest score, had it everywhere. It's not why it got the highest score. It helped. But that team put.
What score did they get?
That was supposed to be 400 out of 400. But they had everything we were looking for as far as the requirements. The proper logo, they had the name of the company, they had the name of the team, they had warnings, and all of that was engraved inside. The picture of all this was
Could you to go through one, is there a way to change where like
Have a great weekend. Don't drink and drive. Your drugs drive without a license.
could you